Welcome back, makers. Have you ever missed an important task or forgotten your medicines on time? Well, not anymore. Today we will make smart reminder clock using an ESP8266, an LCD display, and a tiny buzzer. It doesn't need the internet. It works completely offline, and you can set reminders straight from your phone through a built-in Wi-Fi portal. So, let's get started. This is a 20x4 LCD display with I2C interface. It can show up to 4 lines of text, with 20 characters on each line. Thanks to the I2C module on the back, it only needs 2 data pins from the ESP8266, SDA and SL, making wiring simple and clean. It has potentiometer to adjust brightness of the display, and by removing jumper, you can disable backlight. This display is perfect for our reminder clock project because it gives enough space to show the time, date, and upcoming reminders all at once. This is the Wemos D1 Mini, a compact ESP8266 development board that adds Wi-Fi to your projects. The best part is its small size and ease of programming. It connects directly to the Arduino IDE over micro USB, just like an Arduino board. This is the DS3231 real-time clock module. It keeps track of accurate time even when the main power is off. It has its own coin cell battery backup, so the clock continues to run in the background. It ensures that a reminder clock always shows the correct time, even after a restart or power cut. And here is our simple wiring diagram. Really simple, isn't it? So let's go ahead and connect all parts together. Take Wemos D1 Mini and install it on the breadboard. Take DS3231 RTC Module and install it on the breadboard. Now take red jumper wire and connect VCC pin of the DS3231 to the 3.3 volt pin of the Wemos D1 Mini. Take black wire and connect ground pin of the DS3231 to the ground pin of the Wemos D1 Mini. Take yellow wire and connect SDA pin of the DS3231 to the D2 pin of the Wemos D1 Mini. And at the last, take orange wire and connect SCL pin of the DS3231 to the D1 pin of the Wemos D1 Mini. Now we will connect LCD screen to D1 Mini. Take 2 wires and connect them to the 5 volt pin and ground pin of the D1 Mini. Our LCD screen runs on the I2C protocol. Hence, we will connect screen to the same pins where DS3231 already connected. Connect power pins of the D1 Mini to the VCC and ground pin of the LCD screen. As shown here, connect SDA and SCL pins of the D1 Mini to the respective pins of the LCD screen. And finally, all our connections are completed. You can connect buzzer to the D5 pin of the D1 Mini. Now we are ready for the next part. Connect setup to the PC using data cable, and let's see the sketch. Now let's dive into the sketch. At the top we include the essential libraries, Wi-Fi and web server for the portal, LittleFS for file storage, wire and RTClip for the DS3231 real-time clock, LiquidCrystal for the display, plus time and vector helpers. Right after that are the configuration constants, the access point name and password, the LCD dimensions, file paths for configuration and reminders, and buzzer parameters such as the pin and pulse timings. Next, we declare global objects and data structures. We create the web server, the RTC object, and the I2C LCD. Flags shows 12 or 24 hour time. Here we declare prototypes for helper functions, followed by variables that manage the buzzer state and the timing of reminder checks. Helper functions simplify formatting and safe printing. These formatters build human-readable strings. These utilities make the rest of the code easier and more robust. These functions sanitize and format text so it always fits the LCD, replacing invalid characters and padding or trimming to the correct width. Before printing, each row is cleared to prevent ghost text, ensuring the display always looks clean and consistent. This part of the sketch handles saving and loading settings and reminders using LittleFS. The configuration file stores options like the 12 or 24-hour format and the last notification. Reminders are written into a CSV file with time and label and reloaded on startup so nothing gets lost after a reset. A helper function also parses date and time strings from the browser into proper values for the clock. These functions build the HTML pages for the web portal, including consistent headers, footers, and styles. The portal uses clean card style design, with forms to sync time, switch between 12 and 24-hour format, and add or delete reminders. Each response is wrapped with clear feedback and a button to return to the main portal. These handlers connect the web portal with device functions, like syncing time, toggling formats, and managing reminders. Each action validates inputs, updates files or settings, and responds with clear feedback. In the setup function, the device initializes all its hardware and services. LittleFS is mounted so configuration and reminders can be loaded, and the RTC is checked. If it lost power, it's reset to the compile time. The LCD is initialized and cleared, while the buzzer pin is set up ready for alerts. The ESP starts its own Wi-Fi access point for the portal, and all HTTP handlers are registered with the web server. Finally, the server begins, making the reminder clock ready to use. From this point onward, the system can display time, accept reminders, and respond instantly through the web portal. The loop keeps the web server responsive, updates the LCD, checks reminders, and runs the buzzer pattern without blocking. And with this, we are ready to upload sketch to the D1 Mini. Hit upload button and wait for the sketch to upload to the board. Now let's test the reminder clock in action. When we connect to the Wi-Fi access point, the portal opens in the browser, showing the current device time and date. From here, we can sync the clock with the browser, switch between 12 and 24-hour formats, and add new reminders with custom labels. Each reminder is saved instantly, displayed on the LCD, and will trigger both a notification and a buzzer alert at the right time. The portal is simple and mobile-friendly, so it works smoothly on both desktop and smartphones without needing any apps. Adding or deleting reminders takes just a few clicks, and every action shows clear feedback. On the LCD display, the current time and date appear on the first line, with upcoming reminders shown below. When a reminder is active, it's highlighted clearly, while the last line scrolls useful messages and notifications. This project is not just a fun build, but also a really practical tool for daily life. It can remind you to take medicine, attend meetings, or even water your plants, all without needing an internet connection. The best part is, everything is customizable and runs on a simple ESP board with low power consumption. It's a budget-friendly project that's easy to build, and once complete, it feels like a professional gadget worth using every day. If you enjoyed this project and found it useful, don't forget to hit the like button and share it with others. Subscribe to the channel for more exciting DIY builds, and stay tuned for upcoming projects. Till then, I am DHK Dude, signing off.